Hello, we have already started first chapter, which is review of vector calculus, and we have finished the following topics: overview of vector algebra, dot product and cross product. So in today's lecture we will discuss about the coordinate system. So there are the three types of the coordinate system. First is Cartesian coordinate, second cylindrical coordinate, and third is spherical coordinate. And then we will discuss about how to convert a point and vector from one coordinate system to the another coordinate system. So what we have discussed in last lecture? So in last lecture we have discussed about the dot product and cross product. So in last lecture, first of all, we have to discuss about the dimension, 0 dimension, 1 dimension, 2 dimension, 3 dimension and 4 dimension quantity, and then we discuss about the scalar and vector quantity. So scalar quantity means no direction, it has only magnitude. Vector means it has a magnitude as well as the direction. Then we discuss about how to draw a vector. Okay, so to draw a vector, so for a vector the minimum 2 points are required, A and B. Okay, so if the vector is from point A to B, so here point A is known as tail, point B is head, so it is represented as capital R subscript AB arrow. Okay, so this is a RAB vector. Then we have discussed one example. Okay, so what is a vector? Vector is nothing but actually it's the combination of magnitude and direction. Okay, and which one is indicate the direction? The unit vector is indicate the direction that we have discussed here. Okay, so suppose in this example I would draw one vector. Vector A is equals to 2x plus 4ay plus 3az. So this vector is present in x, y and z direction. Okay, so what is the weightage in the x direction? 2, weightage in the y direction is 4, and weightage in the z direction is 3. Then we discuss about there are the two types of the product of vector: dot product and cross product. A vector dot B vector is equals to magnitude of A, magnitude of B, cos theta, where theta is the angle between these two vectors. And we take one example of any vector. Okay, how can we, okay, so here we have to find out the magnitude and unit vector of the vector. If vector is given, how to find out its magnitude and how to find out the unit vector of this vector. And what unit vector is indicate? Unit vector is indicate the direction of this given vector. Okay, and dot product of A vector dot B is equals to AB cos theta. Then we have to conclude these following cases: ax dot ax is 1, similarly ay dot ay is 1, az dot az is 1, ax dot ay is 0, ax dot az is 0, ay dot az is 0. That means the dot product of the same unit vector is 1, where the dot product of the different unit vector is 0. Okay, and then I have assigned one question: find out the angle between these two vectors. Okay. Then we have also discussed about the cross product. A cross B is equals to magnitude of A vector, magnitude of B vector, sin theta. And what is AN? AN is nothing but it is in normal direction. Okay, it is a direction which is perpendicular to this plane. Okay, it is indicated by AN. So AB sin theta is indicated magnitude, where AN is indicated the direction. Okay, and one most useful thing is if we do the dot product between two vectors, so answer is a scalar. But if we do the cross product between two vectors, so answer must be a vector quantity. Okay, and these are the conclusions. Okay, so now in today's lecture we will discuss about the coordinate system. So first we solve some numericals which is based on dot product and cross product, and then after we will jump to our today topic. Okay, so I will take one example. First example, suppose vector A is given. Vector A is 2ax plus 3ay minus az, and vector B is given. Vector B is ax minus 2ay plus 4az. Okay, so now we have to find out the dot product between two vector and cross product between two vector. How can you find out the dot product between two vector? So it is just vector A dot vector B. And what I will do, I will just do the multiplication of the unit vector. Ax multiply with this ax, ay is dot multiply with this ay, az is dot multiply with az, because we know that ax dot ax answer is 1, ay dot ay answer is 1, az dot az answer is 1. ax dot ay answer is 0, ax dot az answer is 0. So no need to multiply ax with ay and az, no need to multiply ay with ax and az, no need to multiply az with ax and ay. Okay, so what we have to just do the dot product between ax, ay and az. Okay, so which are the coefficient of ax here? 2, and here it is 1. So 2 into 1, 2. Okay, here the coefficient of ay is 3, and here it is -2. So 3 into -2, -6, -1 and 4. Okay, so here coefficient is -1, here it is 4, so it is -4. Okay, so answer is -8. So a dot b is equals to -8. So here -8 is a scalar quantity. Okay, so in this way we have to do the dot product between two vectors. Clear? Now how can we do the cross product? So for generally cross product we have to apply the matrix method, because the matrix method is very easy. You can apply the cross product in this way also. Ax cross ax answer is 0, ax cross ay, then ax cross az, then I will pick up the ay, then do the cross product with ay and ax, ay and ay, az, ay and az. But it's a very lengthy method. Okay, so instead of that I have to apply the matrix method, because the matrix method is very easy method. Okay, so in the first row I have to write all the unit vector, which is ax, ay and az. In the second row I have to write the coefficient of a vector, which is 2, 3, -1. Okay, so here is 2, 3, -1. In the third row I have to write the coefficient of b vector, which is 1, -2 and 4. Okay, now just find out the determinant of this matrix. How to find out the determinant of the matrix? First I have to take ax, okay, then 4 into 3, 12, minus -2 -1, 2. Okay, so 12 minus 2, so 4 into 3, 12, 12 into -2, so this 10, minus ay, 4 into 2, 8. Okay, minus 1 into -1, so this plus 1, so this 9, plus az, 2 into -2, -4, minus 1 into 3, -3, so this -7. Okay, so this one is my answer. So my answer is 10ax. Here answer is 10ax minus 9ay minus 7az. Okay, so this one is the answer for the cross product between two vectors. Okay, so if you notice in this example, if I have to do the dot product between two vectors, so answer is scalar. But if I have to do the cross product between two vectors, so answer is a vector quantity. Okay, so this example is asked in so many ways. Okay, find out the unit vector of a cross b, find out the magnitude of a cross b, okay, or find out the unit vector of vector a, find out the unit vector of vector b. Okay, this example asked in so many ways. Okay, so it's a simple example of how to do a dot product and a cross product between two vectors. Clear? Now we discuss one more example if the point is given. Okay, so the example is like this. Okay, so in this example the points are given. Okay, suppose the given point is point P is 2, 1, 2. Okay, point Q is -1, 2, 3, and point R is, you can take any point, okay, 2, -3, 1. Okay, now find out, okay, find out dot product between two vector. Okay, I have to write P, Q, R. Okay, no problem. So this vector R subscript PQ. Okay, find R PQ vector, comma, find R subscript QR vector, and find dot product between two vector or cross product between two vector. Okay, rpq dot rqr, okay, or rpq cross rqr. Okay, so now how to solve this type of example? So what we have to do, first of all we have to find out rpq vector. Okay, see here, actually what do you mean by rpq vector? Rpq vector means the vector which is present between point p and q. Okay, see here, suppose the point here, it is point p, this one is point q, and this one is point r in Cartesian coordinate system. These are the value of x, y and z. Okay, so now first is rpq, that means the vector which is pointed from p to q. Okay, so this rpq. Then vector rqr, that means the vector which is pointing from q to r. So this rqr vector. Okay, then after we have to do the dot product between these two vector. Clear? So actually what is the difference between a vector and rpq vector? See, actually I have to give just name. Okay, you can give the name rpq as a vector. Okay, actually this one is a different example, but if I want, then I can give the name, this one is my a vector, this one is my b vector. I can give the name like this also. Okay, so no need to write in this way r subscript p q always. Okay, I have to just give the name of this vector. It's a pat name of this vector. Okay, the original name is rpq vector. Okay, but you can give the pat name as a vector, because no need to write all time r subscript pq. Okay, so it's a very lengthy method. Okay, and that means it's a confusing. Okay, so that is why generally we have to use a vector, b vector, c vector, d vector, like that. Okay, generally we have to prefer a vector and b vector. Clear? So in this case, how to find out rpq vector? So that we have already discussed in our last lecture. Rpq vector is equals to coordinate of point q minus coordinate of point p. That means head minus tail. Okay, which are the coordinate of point q? The coordinate of point q is -1, 2, 3. Which are the coordinate of point p? 2, 1, 2. Okay, so just do the subtraction. So -1 -2, so this -3, 2 -1, so this 1, 3 -2, so this 1. But you cannot write vector in this way, it's the point form. Actually we want in terms of vector. Okay, so this minus 3ax plus 1ay plus 1az. Okay, so this one is my vector rpq. Pq, so this q minus p. Similarly rqr, so this r minus q. Okay, so you have to find out this vector separately and then do the dot product or cross product, whatever is given in exam. Okay, so it's just a simple. Okay, you can find out the angle between these two vector also. How can you find out the angle between these two vector? Just do the dot product. Okay, then find out the magnitude, then divide this dot product with the magnitude and find out the cos inverse. Okay, so you can find out the angle between two vector also. It's very easy. Okay, so now let us discuss our today topic, which is coordinate system. So as we know that there are the three types of the first, why the coordinate system is important. See, the coordinate system is important because actually in this subject we have to deal with electromagnetic wave. Okay, so electromagnetic wave is propagated in free space in any materials, in dielectric material, okay, or in conductor or in perfect conductor, okay, or lossy or lossless dielectric material. Okay, so in that case, what is the behavior of electromagnetic wave actually? Okay, and the electromagnetic wave is propagated in which manner, in which polarization? Okay, there are the three types of the polarization: circular polarization, linear polarization, elliptical polarization. Okay, so that is why it is required to study the coordinate system. So there are the three types of the coordinate system. First coordinate system is Cartesian coordinate system. Second coordinate system is cylindrical coordinate system, and the third coordinate system is spherical coordinate system. So there are the three coordinate system: Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. Okay, now the Cartesian coordinate system is represented by which of the variable? So the Cartesian coordinate system is defined by total 3 variable, which is x, y, and z. Okay, cylindrical coordinate system is defined by rho, 5, and z. And spherical coordinate system is defined by r, theta, and phi. Okay, now we'll discuss about all those things. What is x, y, z, what is rho, 5, z, and what is r, theta, and phi. Okay, so first we have to take the Cartesian coordinate system. Okay, so as we know, Cartesian coordinate system is very easy. Okay, because it has only 3 axes. Which are the 3 axes? Okay, x, y, and z. So here I have to draw x, y, and z axis. Okay, you can take this axis as a x, y, and z axis, x, y, and z axis, x, y, and z axis. Okay, it doesn't matter, but generally we have to consider this x axis, y axis, and z axis for our simple case. Okay, so this x, y, and z axis, all the 3 axes are perpendicular to each other, because here this white sheet is a 2D, but whatever the figure I have to draw, the figure is a 3D figure. Okay, so you have to just imagine these 3 axes are perpendicular to each other. Okay, they make 90-degree angle with each other. Okay, so this x axis, y axis, and z axis. So where is negative x axis? This axis is known as negative x axis. Here it is negative y axis. Okay, and this one is negative z axis. Okay, so if one person is standing here at the origin, okay, so it is known as origin. Okay, so now just assume if one person is standing at the origin, okay, or the question is not one person. Okay, suppose I have to put one very big football. I have to put very big sphere. Okay, not football, but very big sphere. I have to put the center of the sphere at the origin. Okay, listen carefully this question. Suppose I have to put the center of the sphere at the origin side. Okay, I have to put the center of the sphere at the origin side. Then how much portion of the sphere is present in positive x and positive y axis? Okay, I have to repeat. Suppose I have to put a center of the sphere at the origin of x, y, and z axis. Okay, so how much portion of the sphere is present in the plane which is positive x, positive y, and positive z? Okay, so the question is 1/8 portion of the sphere. Answer is 1/8 portion of the sphere is present in positive x, positive y, and positive z plane. Okay, how? So see, actually if you look in a 3D view, okay, this one is positive x axis, negative x axis, positive y axis, negative y axis, positive z axis, and negative z axis. Okay, so suppose someone is standing here. Okay, suppose one person is standing here. Okay, so I can say that this person is standing. Okay, this person is standing in which plane? The person is standing in xy plane, at the upper portion of the xy plane. Okay, clear? So there the 3 planes are present: xy plane, then this plane is yz plane, and this plane is xz plane. Okay, so there the 3 planes are present here. Okay, see here, I have to draw only xy plane. So how it look like? This plane is known as which plane? This one is xy plane. Okay, so the person is standing in the xy plane. Okay, clear? So there the 3 planes are present. The first plane is xy plane. Okay, similarly the second plane, okay, draw it. The second plane, it is yz plane. Okay, this plane is known as yz plane. Why it is known as YZ plane? Because it contains Y axis and Z axis, so it is YZ plane. Clear? And last plane, XZ plane. Okay, now to draw the last, which is XZ plane. Okay, so this plane is known as the XZ plane. Okay, so actually there are the three planes are present in Cartesian coordinate system. Okay, so actually this figure is very bad. So now to draw again. So you have to just assume in a 3D view. Okay, so you will get the clear-cut idea about the Cartesian coordinate system, because the Cartesian coordinate system is a basic system. Okay, if you once understand the Cartesian coordinate system, so it's very easy to understand the remaining all the two coordinate system, which are the cylindrical and spherical coordinate system. Okay, so again I have to draw it. So this x-axis, y-axis and z-axis. This one is my negative x-axis, here it is negative y-axis, and here it is negative z-axis. Okay, so suppose I want to locate any point. Okay, I want to locate one point in Cartesian coordinate system. The point P is, you can take any coordinate, suppose it is 2, 3, 4. Okay, I want to locate this point in Cartesian coordinate system. Okay, so here what is 2, 3 and 4? So 2 is nothing but the distance in x direction, 3 is distance in y direction, and 4 is the distance covered in the z direction. So this x, y, z. So value of x is 2, value of y is 3, and value of z is 4. Okay, so how can I locate this point? So first of all, I have to standing at the origin. This one is the origin. I have to cover a 2 step in x direction. I have to cover 1 and 2 step in the x direction. I have to stop here. Okay, then I have to turn. Then I have to cover a 3 step in the y direction. 1, 2 and 3 step. Okay, I have to cover a 3 step in the y direction. Then I have to stop here. Then I have to cover a 4 step in the z direction. Okay, so 1, 2, 3 and 4. Similarly 1, 2, 3 and 4. Okay, I have to cover 4 step in the z direction. So this one is the location of my point P. Okay, so first of all I have to cover 2 steps in x direction. Okay, then after I have to cover 3 step in y direction. Okay, and finally I have to cover 4 step in z direction. Okay, clear? So this one is the final location of my point P. I have to locate the point P in 3D coordinate system. Okay, clear? So this one is very easy, how to locate any point in the Cartesian coordinate system. Okay, now how much plane are present here? Okay, so if you notice, there are the total 3 planes that we have already discussed. There are the 3 planes are present. Which are the 3 planes? First plane is xy plane. Okay, so here first plane is xy plane, this plane. Okay, first plane is xy plane, this plane. Okay, this axis is also included, this negative x-axis is also included. Okay, here this negative y axis is also included. Okay, see here, this one is x, positive x and positive y. Okay, so this plane is known as positive xy plane. This axis is negative x and positive y. Okay, so this one is a negative x and positive y plane. This one is negative y and positive x plane. Okay, and what about this one? Negative x and negative y plane. Okay, so this shade, this orange shade is indicate which plane is a xy plane. Clear? So this whole plane is known as which plane? Is a xy plane. Okay, so there are the total 3 planes are present. Okay, so how many planes are present here? So number of planes. First plane is which plane? First is xy plane, or you can say that xy surface. Okay, xy plane. Now which vector is perpendicular to the xy plane? Of course, z. Which axis is perpendicular to the xy plane? Z axis is perpendicular to the xy plane. Okay, next plane. Next plane is YZ plane. Okay, so first I have to draw YZ plane. Okay, so this one is my YZ plane. Okay, I have to consider positive y and positive z. Now to take negative y and positive z. So this one is also my YZ plane. Okay, so this green is indicate YZ plane. Then after positive y and this negative z. Okay, so this one is also my YZ plane. Okay, then after I consider negative y and negative z. So this one is also my YZ plane. Okay, so this green is my YZ plane. Okay, so this is known as YZ plane. So which axis is perpendicular to the YZ plane? Of course, x axis is perpendicular to the YZ plane. Okay, next remaining is XZ plane. Okay, so now to draw XZ plane. So positive x and positive z. Okay, so this one is my XZ plane. I have to consider positive x and positive z. Now I have to consider negative x and positive z. Okay, so this is my XZ plane. Now I consider positive x and negative y, sorry, negative z. Okay, so this is also a XZ plane. Now I consider negative x and negative z. This is also a XZ plane. Okay, so it is XZ plane. So there, okay, and which axis is perpendicular to the XZ plane? Of course, y axis is perpendicular to the XZ plane. Okay, so there the three planes are present in Cartesian coordinate system: XY plane, YZ plane, and XZ plane. Okay, so the main important thing is XY plane. This XY plane is also known as y is equals to 0 plane. Okay, XY plane is also known as y is equals to 0 plane. So what is the another name of XY plane? Another name of XY plane is, sorry, z is equals to 0 plane. What is the another name of YZ plane? YZ plane is also known as x is equals to 0 plane. What is the another name of XZ plane? The XZ plane is also known as y is equals to 0 plane. Okay, so these are the plane of Cartesian coordinate system. Clear? So this Cartesian coordinate system has a 3 axes. Which are the 3 axes? 3 axes, x, y, and z axis. Okay, and there are the 3 plane: xy plane, yz plane, and xz plane. Okay, so actually the Cartesian coordinate system is very easy. Okay, so no need to discuss about much more about the Cartesian coordinate system. So now we have to directly jump to the next coordinate, which is cylindrical coordinate system. Then what we have to do? We have to compare Cartesian with cylindrical. Then we will discuss about the spherical coordinate system, and we will do the comparison between Cartesian and spherical coordinate system. Okay, so here we have to just do the comparison between Cartesian and the cylindrical, and then after we will do the comparison between Cartesian and spherical. Okay, so that is why the Cartesian coordinate system is our reference. Okay, it's our reference coordinate system. Okay, so we have to compare Cartesian with cylindrical and Cartesian with spherical coordinate system. Clear? So now next is cylindrical coordinate system. Okay, so as we know, the cylindrical coordinate system has a 3 variable: rho, phi, and z. So we discuss what is rho, what is phi, and what is z. Okay, so cylindrical coordinate system. Cylindrical means the shape is like as a cylinder shape. Okay, the cylindrical coordinate system is say that the shape is like as a cylinder shape. Okay, so in today's lecture what we have discussed? So here we have discussed about the first, we do one example, dot product and cross product. Okay, how to do the dot product and cross product between two vector quantities. Then we will discuss about the three coordinate system: Cartesian, cylindrical and spherical coordinate system. Okay, we will briefly discuss about Cartesian coordinate system. There are the three plane x, y, y, z and xz plane. Okay, so in next lecture we will discuss about the cylindrical coordinate system. Thank you.